lesson, we're going to just review the two problems I asked you to try on your own. In a random sample of 371 UCF students, 45 chose the number 7 when picking a number between 1 and 20 at random. Does this provide convincing statistical evidence of bias in favor of the number 7, in that the proportion of students picking 7 is significantly higher than 0.05? Perform a significance test at alpha equals 0.05. Okay, so we need to find our null and our alternative. So the null here, as we saw in previous videos, is p equals 0.05, and the alternative here is going to be p is greater than 0.05. And the way I know that it's greater is because it says significantly higher than. I need to find all of my values and my probability. So here I'm looking for the proportion, my sample proportion, which is 45 divided by 371, which gives me 0.12. And then to find the standard error, that's just going to be the square root of p times 1 minus p over n, and you should get 0.011, and then I'm going to find z, which remember is your p hat minus p divided by the standard error, and you get 6.19. So you can probably estimate now we're trying to find z is greater than 6.19. And remember that this symbol should always match up with your alternative. Okay, so to do that, I need to sketch my model, and I know that the mean is going to go in the middle, and then of course you would add 0.011 and subtract 0.011. But we know we're going to be 6 standard deviations to the right. So we're going to be all the way down the curve. And I'm looking for where it's greater. So you can imagine the probability there, right? The further we go out on the curve, the smaller the probability. So you can do the math without even typing into the calculator here. The probability that z is going to be greater than 6.19 is basically 0. So now, in my last step, so this was basically step number 4, step numbers 5 and 6, I'm going to be rejecting the null. Why? Because 0 is less than your alpha level, so you reject the null. Okay, so anytime you reject a null, you would say there is strong evidence to suggest the alternative. What does the alternative say? That the proportion of students picking 7 is significantly higher. I mean, in our sample, 12% picked the number 7. So I would say that is significantly higher than 5%. In 2008, the Centers for Disease Control and Prevention reported that 34% of adults in the United States are obese. A county health service planning and new awareness campaign polls a random sample of 750 adults living there. In this sample, 228 people were found to be obese based on their answers to a health questionnaire. Do these responses provide strong evidence that the 34% figure is not accurate for this region? So my null hypothesis would be that P is equal to 0.34. It's not asking if it's more than or less than, it's just saying, is it not accurate? So therefore, this is going to be a two-tailed test. So P does not equal 0.34 is my alternative. Now I need to find my calculations. So P hat here is going to be the 228 divided by the 750. And that comes out to 0.304. The standard error of P hat is the square root of P times 1 minus P and then over N. And when you do that, you get that. So Z is equal to your value, in this case your P hat, minus your mean, divided by the standard error. And you get negative 2.08. So I'm looking for the probability that Z, let's just say, is less than negative 2.08. But since it's two-tailed, remember you want to multiply your answer by 2. So if you think about the normal model here, we know that 34% goes in the middle because that's my population proportion of adults that are obese. And we're going to go 3 standard deviations in either way. We know that here our test statistic is 2.08 standard deviations, but we don't know if it's going to be more than that or less than that. So we'll go 2.08 on the left, 2.08 on the right, and we shade right and left. So I'm looking for one of those areas, and I'll just double it. So I'm going to look for where Z is less than negative 2.08. So the probability that Z is less than negative 2.08, I'm just going to do 2 times, so let me rewrite this here. Z is less than negative 2.08 is just going to be 2 times the probability of Z being less than negative 2.08. So that's 2 times normal CDF. So remember to do normal CDF, and I apologize for my marker. Make that a little neater. Okay, my lower bound in this case, since I'm looking at the left of negative 2.08, my lower bound is going to be negative 100. My upper bound is negative 2.08, and my mean and standard deviation are 0 and 1. And when you calculate that, you end up with 0.04, which is right on the cusp, right on the fence of being less than 0.05. So steps 5 and 6, since 0.04 is less than 0.05, okay, which actually, they're so close. For a problem like this, when you're dealing with medical issues, you may want to lower alpha, or you can, take another sample and do it again. So since 0.04 is less than 0.05 by just 0.01, right? It's cutting it close. We're going to reject the null. And anytime you reject the null, remember you say there is strong evidence to suggest what? So it's always the alternative. That in this case, the proportion of obese adults is not 34%. In fact, we can add on to this, our proportion showed that it was about 30.4%. So in fact, it could be less based on our sample, but not every sample is the same, right? So taking lots of samples, replicating gives us more accurate results. So that's the end of this video. Please stay tuned for one more where we look at the errors that can be made when you're rejecting and not rejecting when you do a hypothesis test.